Hello everyone. Today we are talking about day 5, angle measures. And to start, we need to define array. Array is a part of a line that consists of one endpoint on the line, endpoint, and the points on one side of the endpoint. Now, we can have different arrays that we need to be very careful about how we name. So the array I just drew with the endpoint of A that continues towards B would be array AB, which I name by writing the endpoint first, followed by the following point with an arrow. Now I could also have array DC, and that would have to be named array DC because I always start with the endpoint when I'm naming it. Opposite arrays are two collinear arrays, meaning they have to be on the same line with the same endpoint. So I have array AB and array AC. So even though array AC is going left, that is still array AC. And I can represent that, I can name that by saying it's line CAB, or it's array AC and array AB. Again, when you're naming an array, you always put the endpoint first. So use the figure at the right for 1 and 2. Name all labeled arrays. And then number 2, name opposite arrays with endpoint T. Name another pair of opposite arrays. So I want you to try these two problems. So you're going to pause and then come back and check your answers. Okay, so name all labeled arrays. So I have RS, ST, TW. Notice that I only have one endpoint, or one letter and endpoint one time, because if RS is the same array as RT, it's the same array as RW, because remember, arrays at the other end keep going. And then I can go to the left, so I have WT, TS, and SR. Name a pair of opposite arrays, so TW and TS, or I could have named that also as TW and TR. Another pair of opposite arrays are SR and SW. There aren't any opposite arrays with endpoint of W because there's no points to the right that are labeled, and there aren't any opposite arrays with R as the endpoint because, again, there's no endpoints. Angle is the set of all points that is the union of two arrays having the same endpoint. So an angle is an angle, and we can name an angle 3 different ways. So I can name it by a capital letter where the point is the vertex. I can name it with a lowercase letter inside or a number inside. So that's angle A up there. This would be angle A or angle 1. And then the most common way that makes sure you're talking about a specific angle is 3 letters. So I could name this angle, angle DEF. Now when you are naming it using 3 letters, your middle letter has to be the vertex. So this could also be angle FED, but the E must be the middle. Types of angles, I'm assuming you know most of these. Right angle has a 90 degrees, so or it equals 90 degrees. And we always represent that by putting a little box. Straight angle is our opposite rays, so it's 180 degrees. Acute angle is more than 0, but less than 90. So there's our acute angle. Obtuse angle is is greater than 90, but less than 180. And there's an example of our obtuse angle. Congruent angles have the same measure. So ABC is congruent to DEF. So that means when I draw them, I would label them congruent by putting a little arc over the angle. And that would mean, say, these are both 30 degrees. Angle bisector is a ray whose endpoint is on the vertex of the angle, and it divides it into two congruent angles. So if I have this angle, A, B, C, and I have ray DI or BD, it bisects if angle ABD is congruent to angle DBC. Means that BD bisects angle ABC. So now we have a couple of examples to do. So I want you to try these. Or actually, I'm going to help you set up the first one, then I want you to try the second one on your own. So it says if LKM equals 7x minus 5, so that's this big angle right here, and NKM is 3x plus 9, find LKM. Now, it's important that we go up here and read the fact that KN bisects LKM. So if KN bisects LKM, that means NKM is congruent to LKN. So that means that 2 times angle, or the measure, that's what this little m is, this means measure, 2 times the measure of NKM is equal to the measure of angle LKM, because KN bisects. So that means I'm going to do 2 times 3x plus 9 equals 7x minus 5. And then we're going to do that algebra. And I get that x equals 23. That didn't answer my question. They want me to find the measure of LKM. So the measure of LKM is 7x minus 5. So I'm going to do 7 times 23 minus 5. So that's 161 minus 5. So that's 156. So I want you to pause, do number 10, come back and check. Okay, so for number 10, it's a little bit tricky, so we have to think about it a little bit. So NKL is 7x minus 9, and that's equal to NKM, which means the big angle, LKM, is twice that. So LKM is 14x minus 18. The reason why I needed to know that is the other angle they gave me is JKM. And the only thing I know about JKM is that JKM and MKL are a straight angle because they're on opposite rays. So that means JKM plus LKM equals 180 because it's a straight angle. So I use that and I find out x equals 13. Once I know x equals 13, I can find that JKM is 16. And I can find that NKL is 82. So then JKN is 16 plus 82, or 98. If you have questions about that, please ask me tomorrow in class. So in that problem, we used something that we're going to talk about now, which is angle addition, which is when two angles are adjacent, you can add them. So here it's given that RST is 50 and TSW is 35. And since they both have TS, that means they're adjacent. So RST. And then TSW. So this is 50, this is 35. So that means the measure of angle RSW is 85. So then we can use that down here. So if we know AOB, which is this little tiny angle right here, is x plus 3, and we know AOC, which is the larger one, is 2x plus 11, and we know BOC is 4x minus 7. So if we look at that drawing, we know that measure of angle AOB plus the measure of angle BOC is equal to the measure of angle AOC. And then you're just going to do that algebra. So I'm going to pause. Okay, so I paused and I quickly did that algebra. That gives me that x equals 5. They want me to find all the angle measures. So I start with the measure of angle AOB. And so that's 5 plus 3. So that's 8. The measure of angle AOC is 2x plus 11. This was x plus 3, I didn't write it. So that's 2 times 5 plus 11. So that's 21. And then the measure of angle BOC is 4x minus 7. So that's 4 times 5 minus 7. It's 13. And if we do a quick check, 8 plus 13 does equal 21. Angle subtraction is very, very similar. That when angles form a larger angle, you can subtract. So it's just like angle addition, except for we're kind of doing the opposite. So again, if we look here, we know that COD is 9x plus 4. And we know that BOC is 4x minus 1. And we know that BOD, which is large angle, is 14x minus 6. So I can do that the measure of angle BOD minus the measure of COD equals the measure of BOC. And I actually could have reversed COD and BOC as well. So I can say that 14x minus 6 minus, and it's important you put this in parentheses because you got to distribute that negative, 9x plus 4 equals 4x minus 1. And again, I'm going to pause to do the algebra. You finish it and come back and check. Okay, so I did my algebra there. I came up with x equals 9. I then substituted into COD and found out COD is 85. Substituted into BOC and found out BOC is 35. And BOD and found out BOD is 120. So then here are 6 more problems that I want you to do based on the drawing. So pause, do them, and come back. This classwork will take place tomorrow in class. Okay, so there are the answers to those problems. Again, any questions on anything, please bring to class. Have a good night.